Hello everyone. In this video, we are going to talk about a very unique feature of Java that is known as Java generics. So, let us look at an example. Okay, suppose you have written a program to implement a stack of integers. So, a stack of integers will have some numbers and then it will have operations like push and pop and so on. Now, if you want to have an array a stack of let's say floating point numbers, or you want to have a stack of characters, then you will have to write the whole program again, because now you're dealing with a different data type. So how about, without having to redo the entire program, can I make the data type of the elements that the stack will contain a parameter? So if I say stack with integer, then it will give me an integer stack. If I say stack with character, it will give me a character stack. So is this possible? So in Java, it is possible. From Java 5 onwards, there is this concept called Java generics, which allows us to create parameterized types. So let us see what is it. So this generics, it makes it possible to create classes, interface and methods that will work in a type-safe manner with various kinds of data. And when I say type-safe, I mean that when you are converting from one type to another type, then there is no errors. Okay? So it will work for all data types. So this allows us to define an algorithm once and independent of any specific type of data. And then this algorithm can be applied to a wide variety of data types. So this is possible through generics. So generics also means parameterized types. So the type is given as a parameter to the algorithm. And so if you give integer, the algorithm will work with integer. If you give character, it will work with character, and so on. And these parameterized types can be used for a class, for an interface, or for methods. Okay, so that if a class, interface, or method that operates on a parameterized type is called a generic, or you can call it specifically a generic class, a generic interface, or a generic method. So how do we create a generic? Okay. First we'll look at a class. So creating a generic class. So first of all, we have here, this is how we define a class name, and then the body of the class. So here we have added something more, which is within this less than greater than symbol, we have put this capital T. So here T stands for the name of a type parameter. So here T is like the parameter name. Okay, and here we are going to specify, we are going to create or we are going to specify what is the type that we want. So this is an example. So I have a class here called gen, and then here I have given the parameter T within the less than and greater than symbol. Then here inside the body of the class, I have one data member obj, and the obj, the type of, here normally what we give the data type. So here we are given T. So that is the parameter T that we are getting it from here. Then this is the constructor gen, T and O. Okay, so O is of type T. So this O that we are passing from the constructor is assigned to the data member obj. Then there is a method called getObj, which returns an object of type T. So it returns obj, and what is the return type of obj? Obj type is T, so return type is T. Then there is another method called showType. So in showType, what we're doing, we're simply printing whatever is the type. So type is obj.getClassName. So whatever is the class of obj, whatever is the type of this, getName will return me the name of the data type. Now here one point to remember is that this obj here is an object is a reference type. Okay, so when this is returned, I will be able to work with only your wrapper classes. I won't be able to work with primitive data type. So here when I'm saying this is a parameterized type, I mean a parameterized wrapper type. So if you look at the video on wrapper classes, you will be able to see that there are integer, double, character, boolean wrapper classes, which are used in place of the primitive data types. So generics will work only for these wrapper classes. So here I cannot, in place of T, I cannot give a primitive data type like int. So keeping that in mind, let us see now how we are going to create objects. So this was defining the class. Here we have defined the class. So gen is the class and T is the parameter. So when we create object of the generic class, we create in the same manner class name. Now here we give the type. This is where we give the type. And this was again object name is assigned new. Okay, so wherever we are using the class name, we are along with that we are also specifying the data type. So this is the main function where we are testing gen. So gen test in the main. So you can see here gen integer obi is new, gen integer and 100. Okay, so that T that was there in our class here, so in place of T now we are passing integer. Remember integer, this is the wrapper class for integer. It is not the primitive data type int. So, and one more thing to be noted here, we have given as argument, we have given what? The integer 100, the primitive integer 100. And it is automatically converted. If you see here in the constructor, I have capital TO. So this was replaced by capital integer. Okay, so this is an integer object, whereas this is an integer primitive data. So automatically this is converted into the integer class, object of the integer class. So this is your auto boxing. So again, refer to the video on auto boxing and auto unboxing to know more about this. So this first statement, it creates an object obi, which is of type generic integer. So here what we're doing, we are printing the value of this is obi.getObj. So this was the method getObj. So it returns this object of type integer. So this is displayed out here. And then obi.showType. So this is going to show the type of the object. So this was what is going to get executed. So get name. So it should return integer. The second object we have created is obs. Now here instead of integer we are passing string. Okay, and here we have given a string. So this string is auto boxed or auto wrapped into the string object, and this is sent to as a constructor to the gen class. And again same way we are printing the value obj and show type. The third one is boolean. Now we have made obb, which is boolean type. Okay, and we are initializing it with the value true, and here this we are giving an output, and here it is showing the type of OBB. So in this example, so we have created a class of generic type, a generic class, and with one type argument, and we are creating objects of this generic type, 3 different objects. One is of type integer, one is of type string, and one is of type boolean. So using one class itself, I can have 3 different types of objects. One integer, one string, and one boolean. I don't have to write the code again for different data types. So this flexibility is given by the generics facility, the generic concept of generics. So let us first run this program and see what happens.